How do you move hundreds of tons across cities and skies? Discover extreme heavy transport and the giant cranes that lift the impossible. The video captures the extraordinary transport of a 640,000-pound petrochemical splitter moving through Edmonton in the early hours of January 7th. At approximately 12:10 a.m., the massive load carefully approached the intersection of White Mud Drive and 50th Street under strict traffic control and escort supervision. Due to its enormous weight and dimensions, the splitter was mounted on a multi-axle hydraulic trailer system designed to evenly distribute the load and ensure stability during the slow, precise journey. This petrochemical splitter is destined for the Heartland Petrochemical Complex, currently under construction outside Fort Saskatchewan. Once installed, the splitter will play a critical role in the petrochemical production process. Its primary function is to separate propylene from propane through a highly controlled distillation process. After separation, the propylene will be further processed into polypropylene, a versatile and recyclable plastic widely used in packaging, automotive components, textiles, and consumer goods. The successful transport of such a massive industrial component demonstrates advanced logistical planning, heavy-haul engineering expertise, and the scale of investment in Alberta's growing petrochemical industry. A challenging recovery exercise is demonstrated during a professional heavy-duty towing course. In this scenario, Bruce from Service Towing performs a complex lift using one of their HIMNRC 60/80ths SR rotators. The task involves lifting, sliding, and rotating a fully loaded tanker and tractor with a total weight of 81,000 pounds. The massive tanker is carefully secured with heavy lifting straps attached to the boom of the rotator. With precise control, the operator gradually raises the load off the ground, maintaining perfect balance and stability. The hydraulic boom system provides the power and flexibility needed to safely maneuver such extreme weight. This training exercise highlights advanced rigging techniques, load control, and safe heavy recovery procedures. It demonstrates both the capability of the NRC 60/80ths SR and the high skill level required to handle super heavy lifts in real-world recovery operations. The impressive transport of a massive 400-ton tank in Genk, Belgium. The tank measures an extraordinary 74 meters in length and 8.4 meters in width, making it a highly challenging load to move by road. To accomplish this task, specialized S-modules from the Faymonville Model Max system were used. Model Max is an advanced modular road transport platform that can be configured in multiple combinations, allowing it to handle extremely heavy and oversized cargo. When combined, these modules are capable of supporting a total load capacity of up to 5,000 tons. Careful planning, precise steering control, and synchronized hydraulic systems ensured stability throughout the journey. This operation demonstrates modern heavy haul engineering, where modular technology enables the safe and efficient transportation of enormous industrial components. The impressive nighttime assembly of the powerful Liebherr LTM11200-9.1. This 200-ton all-terrain crane is one of the largest telescopic mobile cranes in the world, and its installation requires careful planning, precision, and teamwork. As night falls, transport trucks begin arriving at the site, each carrying a different component of the crane. Due to its enormous size and weight, the crane cannot travel fully assembled. Instead, major parts such as the carrier, superstructure, outriggers, counterweights, and boom sections are transported separately. Under bright floodlights, workers carefully position each part in the designated assembly area. The first stage involves preparing the ground and positioning the main carrier. Once parked, the outriggers are extended and set firmly to ensure stability. After the base is secured, the upper structure is lifted into place and mounted onto the carrier. Technicians work methodically, connecting hydraulic lines, electrical systems, and control components. Next, the telescopic boom sections are assembled. Additional lifting equipment assists in raising and aligning the long boom elements. Each connection is checked and tightened to meet strict safety standards. The counterweights are then installed at the rear of the crane to balance the massive boom. These heavy slabs are lifted one by one and secured precisely according to the lifting configuration. Throughout the night, coordination between operators, riggers, and supervisors is essential. Communication ensures that every lift is executed safely and efficiently. Despite the darkness, the site remains brightly illuminated, allowing the crew to maintain accuracy and visibility. By the end of the operation, the towering crane stands fully assembled and ready for heavy lifting tasks. The nighttime assembly not only minimizes daytime traffic disruption, but also demonstrates the expertise and professionalism required to build a machine of such extraordinary scale. The process of using the Liebherr LTM 1750 to move and lower a large power transformer onto a transport vehicle was carried out with very high precision and safety. First, the LTM 1750 crane was deployed at the construction site on a solidly reinforced foundation. With its 9-axis boom configuration and full extension outriggers, the crane quickly achieved the necessary stability for the super heavy lifting task. Counterweights were installed according to the calculated lifting plan, ensuring optimal load-bearing capacity throughout the operation. After completing the preparation work, the crane began extending its 52-meter-long telescopic boom, adjusting the lifting angle to match the transformer's position. Thanks to its maximum lifting capacity of 800 to 900 tons, the LTM 1750-9.1 easily met the lifting requirements of this very large piece of equipment. The cables and hooks are precisely attached to specialized lifting points on the transformer body, ensuring the load is evenly distributed. Next, the operator performs a slow test lift to check the stability and responsiveness of the load. When all parameters meet the requirements, the transformer is slowly and carefully lifted from the support platform. Throughout this process, the lifting speed is maintained at a low level to minimize vibration and protect the equipment's structure. Once the transformer has reached the required height, the crane begins to rotate its boom to move the load into the correct position on top of the specialized transport vehicle. Thanks to its large working radius of over 110 meters and precise control system, the load is perfectly aligned with the vehicle's floor. Finally, the transformer is gently lowered, placed in its designed position, and securely fixed, ready for transport. The entire process demonstrates that the LTM-1750-9.1 is not only one of the world's most powerful telescopic cranes, but also the ideal solution for ultra-heavy industrial equipment lifting tasks requiring absolute precision and safety. The assembly process of the Liebherr LG1750 is a carefully coordinated operation that combines heavy logistics, precision engineering, and strict safety control. Known for its outstanding lifting capacity and mobility, this crane is widely used in demanding projects such as wind turbine erection. The setup procedure must therefore be executed methodically to ensure both stability and efficiency. The first stage is site preparation. Before any crane components arrive, the construction team prepares a solid and level foundation. Ground pressure calculations are performed to verify that the soil can safely support the crane's weight and the additional loads during lifting operations. If necessary, steel plates or crane mats are installed to distribute the load evenly. Proper site preparation is critical because it guarantees stability throughout the entire assembly and lifting process. Next comes the delivery and positioning of the crane components. Due to the crane's modular design, major parts are transported separately by truck. These include the massive lattice boom sections, the luffing jib components, the superstructure elements, and the heavy counterweights. Once on site, each component is unloaded and arranged systematically according to the assembly plan. This organized layout ensures smooth workflow and minimizes unnecessary movement of equipment. The assembly of the main boom begins with the installation of the base section onto the carrier. Using smaller auxiliary cranes, technicians lift and connect each lattice boom segment one by one. High-strength pins secure the connections, and alignment is carefully checked at every joint. After the main boom reaches the required length, the luffing jib is assembled in a similar manner. The lattice structure design reduces weight while maintaining exceptional strength, allowing the crane to reach impressive heights, especially for wind turbine construction. Following the boom assembly, heavy counterweights are installed. These counterweights are essential for balancing the crane during lifting operations. They are lifted into position using support cranes and attached securely to the superstructure. At the same time, technicians rig the hoist ropes through the sheaves and winches. This step requires precision, as correct rope tension and routing are vital for safe and efficient lifting performance. Finally, comprehensive safety checks and functional tests are carried out. Engineers inspect all mechanical connections, hydraulic systems, and control units. Load tests may be performed to confirm operational readiness. Only after all systems pass inspection is the crane approved for service. Thanks to its mobile carrier design, the LG 1750 can be assembled more quickly than traditional crawler cranes. This faster setup significantly improves efficiency on large projects, making it an ideal solution for heavy lifting tasks in modern infrastructure and renewable energy construction. On the 3rd of December 2017, ALE carried out a highly complex heavy haulage operation to transport a 608-ton transformer from the factory on Weston Road in Stafford to its destination in Congleton. The move required detailed planning, route surveys, traffic management, and close coordination with local authorities to ensure the safe passage of this exceptional load. The operation began at the manufacturing facility on Weston Road, Stafford, where the massive transformer had been prepared for transport. Due to its extraordinary total weight of 608 tons, the load was mounted onto a specialized multi-axle modular trailer system designed to distribute the weight evenly across the road's surface. Engineers carefully checked axle loads, hydraulic suspension levels, and steering systems before departure. Every detail was verified to guarantee stability and safety throughout the journey. Once the load was secured, the convoy moved out of the factory under strict supervision. The route had been selected in advance to avoid weak bridges, tight turns, and restricted overhead clearances. The transporter proceeded toward the A34, where significant traffic management measures were already in place. To facilitate the movement of the abnormal load, sections of the A34 carriageway were temporarily controlled, allowing the convoy to use the full width of the road when necessary. At key junctions, traffic was stopped and diverted to create safe maneuvering space. One of the first major obstacles was the A34 Darlaston Lane roundabout. Because of the transformer's size and length, the transporter required precise steering adjustments. The hydraulic steering system enabled the rear axles to follow a controlled path, preventing encroachment onto roadside structures. Skilled operators coordinated their movements using radio communication to ensure the trailer negotiated the roundabout smoothly. The journey then continued toward the London Road and Barracks Road junction in Newcastle-under-Lyme. This busy intersection demanded additional traffic control and careful timing. Police escorts and traffic management teams worked together to temporarily halt surrounding vehicles. The convoy advanced slowly, maintaining constant monitoring of ground conditions and vehicle alignment. Further along the A34, the load approached the Talk Road gated roundabout. Here, the complexity of the maneuver increased due to restricted space and surrounding infrastructure. The transporter again utilized its multi-directional steering capabilities to reposition the trailer gradually around the curve. Spotters positioned at multiple vantage points provided real-time guidance, ensuring that curbs, signs, and lighting columns were protected from contact. The next challenge was the A34 Talk Village roundabout. Similar to previous roundabouts, this location required the convoy to use controlled sweeping turns. Temporary road closures were implemented to allow sufficient turning radius. The entire operation moved at a very slow speed, emphasizing precision over pace. Throughout the journey, safety remained the top priority. As the transporter entered the Kidsgrove area, responsibility for the escort transitioned. At this point, Cheshire Constabulary was waiting to take over the police escort duties. The handover between Staffordshire authorities and Cheshire Constabulary had been pre-arranged, ensuring seamless coordination across county boundaries. Communication between escort teams ensured there were no interruptions in traffic control or public safety measures. Meanwhile, the Staffordshire TST team, having completed their escort responsibilities, returned to Stafford once the load had safely crossed into Cheshire jurisdiction. Their role in managing the early and most complex sections of the route was successfully concluded. The convoy then continued toward Congleton under the supervision of Cheshire Constabulary. As the destination approached, additional site preparations had already been completed to accommodate the transformer's arrival. Ground-bearing capacities had been verified, and positioning equipment was ready for final placement operations. Transporting a 608-ton transformer over public roads is an extraordinary engineering achievement. Such operations require months of planning, including route analysis, structural assessments of bridges and roadways, and coordination with multiple stakeholders. Every junction, roundabout, and carriageway section along the route must be evaluated to ensure it can safely withstand the concentrated axle loads. This project demonstrated ALE's expertise in heavy transport and logistics management. The successful movement from Western Road and Stafford to Congleton highlighted not only the capability of specialized heavy haulage equipment, but also the importance of teamwork between engineers, drivers, police escorts, and local authorities. Despite the size and weight of the load, the operation was completed efficiently and without incident. Careful preparation, Precise maneuvering and coordinated escort support ensured that the transformer reached its destination safely. The December 3, 2017 transport stands as a remarkable example of large-scale infrastructure logistics executed with professionalism and technical excellence. The impressive transport of a massive alternator from Cottam Power Station to West Burton B Power Station. This Unit 1 alternator is estimated at around 450 MVA, making it one of the largest electrical machines used in modern thermal power generation. Due to its enormous size and weight, the alternator was transported using a specialized heavy-haul trailer system operated by ALE. Interestingly, the component being moved appears to be only the outer casing. Large alternators of this scale are typically shipped in sections. The stator core and windings are often transported separately and assembled on site to reduce transport weight and minimize risk. In this case, the machine is clearly incomplete. The massive end covers, bearings, and rotor are absent, replaced by temporary blanking plates for protection during transit. Traditionally, alternators of this capacity use hydrogen-cooled rotors combined with liquid-cooled stator windings to efficiently dissipate heat generated during operation. Although the exact manufacturer of this unit is uncertain, such cooling systems are standard in high-capacity generators. Following behind the alternator transport, viewers can also see the exhaust diffuser from the power turbine, which will later connect into the boiler ducting system at the destination plant. The journey through normally quiet villages attracted a large crowd of spectators. Residents gathered along the route to witness the careful and highly coordinated movement of this extraordinary piece of engineering, highlighting both the technical challenge and public fascination surrounding heavy industrial transport. In the quiet hours of the night in Minnesota, an extraordinary heavy-haul operation moves forward while most people are asleep. The cargo is truly massive, measuring 215 feet 7 inches long, 21 feet wide, and 24 feet 10 inches high, with a total weight of 670,000 pounds. To understand its scale, this single load is nearly twice as tall, 3 times as wide, 4 times as long, and 5 times heavier than a typical semi-truck. Despite its enormous dimensions, the transport is carefully engineered to protect the roadway. A specialized multi-axle trailer distributes the weight across a large number of tires, ensuring that the pressure per square inch on the pavement does not exceed normal legal limits. Police escorts, pilot vehicles, and detailed route planning allow the convoy to pass safely under bridges, around tight corners, and through intersections. Moving at night reduces traffic disruption, making this complex and highly coordinated operation both efficient and safe. The extraordinary movement of a massive generator rotor from the Callaway nuclear plant for refurbishment This rotor, a critical component of the power generation system, required highly specialized logistics due to its enormous size and weight. The total combined weight of the transport vehicle and its load exceeded 700,000 pounds. To handle such an extreme load, the transport team used a heavy multi-axle trailer system designed to distribute weight evenly across the road surface. In total, 108 tires were in contact with the ground, ensuring stability and minimizing road stress. The operation required two powerful trucks, one positioned at the front to pull, and another at the rear to push. This coordinated push-pull configuration provided the necessary traction and control, especially when navigating inclines and tight roadway conditions. One of the most impressive moments occurred when the convoy turned north onto Highway 19 in Montgomery County. Instead of making a wide, uncontrolled swing, the trailer demonstrated its advanced steering capability. Every axle of the trailer could pivot, allowing the entire platform to bend smoothly around the corner. This synchronized steering system enabled the enormous load to navigate the intersection with precision and safety. Overall, the transport of the generator rotor highlights the complexity of heavy industrial logistics. Careful planning, specialized equipment, and skilled operators were essential to ensure that this oversized component could travel safely for refurbishment before returning to service. A remarkable special transport operation carried out at night from a manufacturing plant. The cargo is an extremely long industrial tank, carefully prepared for departure after final inspection at the factory. Due to its extraordinary length and weight, the transport requires detailed planning, official permits, and coordination with traffic authorities. The operation begins late in the evening to minimize disruption to daytime traffic. Powerful tractor units slowly pull the oversized tank mounted on a multi-axle modular trailer. Escort vehicles travel in front and behind the convoy, ensuring road safety and temporarily stopping traffic when necessary. Warning lights flash continuously, clearly signaling the presence of the heavy load. As the convoy leaves the factory gate, the driver maneuvers cautiously through narrow industrial roads. At intersections and roundabouts, the team works together to guide the trailer's rear steering system, allowing the long tank to pass safely. Overhead cables, bridges, and tight corners demand precise control and constant communication. Throughout the night, the transport advances steadily, demonstrating professional teamwork, advanced logistics planning, and the high level of expertise required for oversized industrial cargo delivery. In this project, an oversized industrial component weighing 175,000 pounds and measuring 127 feet in length is lifted directly from a cargo vessel and transferred to land transportation equipment without intermediate storage at the port. Using a high-capacity dockside crane, the massive load is carefully hoisted from the ship's hold. The cargo is securely wrapped and protected, while lifting slings and rigging systems are precisely positioned to maintain balance and structural integrity during the lift. Engineers and rigging specialists closely monitor the center of gravity to ensure stability throughout the operation. Clear communication between the crane operator and ground crew is essential to guarantee safety and accuracy. Once suspended above the dock, the load is slowly maneuvered and aligned over a specialized CCC beam and dolly trailer system. This heavy-duty trailer is specifically designed to distribute extreme weight across multiple axles, reducing ground pressure and allowing safe highway transport. The beam configuration supports the extraordinary 127-foot length, while the dolly assemblies provide steering flexibility during movement. As the cargo is lowered onto the trailer, crew members in high-visibility safety gear guide the placement to ensure precise positioning. After securement procedures are completed, including load fastening and final safety inspections, the heavy haul convoy prepares for transport to its final destination. This direct discharge method minimizes handling, reduces port congestion, and enhances efficiency. It reflects contractors' cargo companies' expertise in managing complex, oversized freight with precision, safety, and advanced heavy-haul engineering solutions. As the cruise vessel SV Eucalyptus approaches Port des Minimes, the most critical phase of the overland transport begins. After traveling slowly through regional roads on a multi-axle hydraulic trailer, the convoy reduces its speed even further as it nears the harbor entrance. Escort vehicles block intersections, and traffic is temporarily halted to allow the oversized load to pass safely. The massive hull towers above the transporter, creating a striking scene as it moves carefully toward the waterfront. Upon reaching the port area, the transport team aligns the trailer precisely with the designated lifting zone along the quay. Engineers and crane operators conduct final safety inspections, checking lifting points, slings, and load distribution calculations. Communication between ground crews and crane operators becomes constant and highly coordinated, as even a minor imbalance could affect stability during the lift. Two heavy-duty mobile cranes are positioned on either side of the vessel. Their outriggers are fully extended to ensure maximum stability, and thick steel cables are attached to reinforced lifting points on the hull. Once everything is secured, the cranes begin to apply tension gradually. The enormous weight of the SV Eucalyptus slowly transfers from the trailer to the cranes. The trailer's suspension decompresses as the hull rises steadily into the air. With remarkable precision, the vessel is lifted clear of the transporter. The cranes then rotate carefully toward the water, moving in perfect synchronization. Every motion is slow and deliberate. Onlookers gather at a safe distance, watching as the ship hovers above the harbor basin. At the signal from the lead supervisor, the cranes begin lowering the vessel toward the water. The hull descends inch by inch until it gently touches the surface. As buoyancy takes over, the ship settles naturally into the harbor. The lifting slings are loosened and carefully detached once stability is confirmed. The successful launch marks the completion of an intense and technically demanding operation. From the final meters of road transport to the precise crane-assisted lowering, the arrival of the SV Eucalyptus at Port des Minimes demonstrates exceptional coordination, engineering expertise, and careful planning.